This is part 2 of the Unit 3 review for Applied Stats. This part is about confidence interval problems. These are going to be ones that involve two samples. So the first one is the same example we looked at with hypothesis testing. This is where we have the mean claims for two different sets of drivers. But this time, instead of doing a hypothesis test, we're going to construct a confidence interval to estimate the difference between the mean claims of the two groups of drivers. So in StatCrunch, because we're talking about two different means, what we want to use anytime we're talking about a mean is the t-stats. This time we've got two sample with summary. So we're going to put in our sample mean, sample standard deviation, and sample size for each of the two groups. We want to do it in the same order that they come up in the question. So we're first going to put in the information for the 20 to 24-year-old drivers, and then we'll put in the info for the 30 to 59-year-old drivers. And there's our info for the two different groups. Then we want to construct a 90% confidence interval. We want to click on confidence interval and change that to 90. And then when we click on compute, here's the information that we get. Here's our lower limit and our upper limit. These are for the difference between the two means. The lower limit of the difference between the means is 73.2. The upper limit of the difference between the means is 1686.8. That's our confidence interval. If we wanted to interpret this confidence interval, we could say we are 90% confident that the difference between the mean claims of the two groups is between $73.17 and 1686.83. When we ask whether the results suggest that there's a significant difference in claims for the two groups, what we're looking at for this one is whether the confidence interval includes 0 or not. Since both of our limits are positive values, that means that 0 is not included. That suggests that there is a significant difference in the claims. For the next one, this is the information about the infants that use the insecticide-treated bed nets or not. Again, we're doing a confidence interval to estimate the difference in the incidence of malaria for the two groups. The incidence of malaria is a proportion. So we're doing a confidence interval for the difference between the two proportions. In StatCrunch, we're going to use proportion stats to sample with summary, since we have summary data. For each group, we're going to put in our number of successes and the number of observations. Again, we want to do this in the same order that it's listed in the problem. So first is the infants that did use bed nets. That's 21 out of 301. Our number of successes is 21. Our number of observations is 301. For the other group, there were 26 out of 272 that got malaria. So our number of successes is 26, and our number of observations is 272. This time we're doing a confidence interval, and we want to make this 95%. Here are our results. This time our lower limit is negative and our upper limit is positive. Notice that these are pretty small numbers because we're talking about proportions now. To interpret this confidence interval, we could say we're 95% confident that the difference between the incidence of malaria for infants using bed nets and infants not using bed nets is between negative 0.071. You do need to include the negative here. Or if we wanted to write that as a percentage, we could say negative 7.1%. And then the upper limit is 0.019, or we could say 1.9%. This time our interval does include 0. That suggests that there's not a significant difference in the incidence of malaria between the two groups. Because this interval includes 0, that means that the difference between the proportions could actually be 0, which would mean that they would be the same. Since there's not a significant difference between the two groups, that suggests that the bed nets are not effective. They're not having an effect of lowering the incidence of malaria. The last confidence interval problem here is for the problem where we have the items and the prices at the store and at the competitor's store. This time we want to construct a 95% confidence interval to estimate the mean difference in prices for specific items at the two stores. In other words, if we took each of these items and took the store's price and subtracted the competitor's price, that would give us the difference between the prices for each different item. Because we've got each item and the two different prices that we're subtracting, that means that this is a paired sample. In StatCrunch, we would take the data and copy it into StatCrunch, and then what we're doing is t-stats paired. So sample 1 is in the store column, sample 2 is in the competitor column. What we're doing this time is a confidence interval, 95%. Here are the results for our confidence interval. Again, this time we have one limit that's negative and one limit that's positive. This is saying that the difference between prices for specific items is somewhere between negative 28 cents and positive 10 cents. That means technically the difference could be 0, which would mean that the prices were the same. Since the interval does include 0, that suggests that there's not a significant difference in the prices.